So let's look at some powers of 10 and changing numbers to scientific notation. 345,000. The decimal point's right here. I'm going to move it over 1, 2, 3, 4, 5 places. So I get 3.45 times 10 to the 5th. Or 6,700, I move the decimal over 1, 2, 3 times. So it's 6.7 times 10 to the 3rd. Or 98,600,000,000. I move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9.86 times 10 to the 10th. We can go the other way. 0.025. In this case, I'm moving the decimal the other way. 1, 2 positions. So it's going to be 2.5 times 10 to the minus 2. The minus means I'm moving the decimal that direction. Or 0.66700 is going to be 6.77 times 10 to the minus 1. I'm moving the decimal point only over 1. Or 0.000000986, I'm going to be moving a 1, 2, 3, 4, 5, 6, 7. So 9.86 times 10 to the minus 7. Now another unit of distance besides the meter that we might use is something called the light year. Light travels about 3 times 10 to the 8th meters every second, or 186,000 miles every second. That's about 7 times around the world at the equator in 1 second. So a light year is a distance that light can travel in 1 year. We can figure out how that is. We take 3 times 10 to the 8th meters per second. We say, well, there's 60 seconds in a minute. There's 60 minutes in 1 hour. There's 24 hours in 1 day. There's 365.25 days in 1 year. And that's going to give us, if we multiply these out, notice that the seconds go away, the minutes go away, the hours go away, like algebraic things, the days go away. I get meters per year. And I multiply by 1 year, and I get then that a light year is 9.5 times 10 to the 15th meters. The above example that we just looked at is an example of converting units. Astronomers have a large sense of time also. So for example, the Earth revolves around itself once per day. The Moon revolves around the Earth in 1 month. The Earth revolves around the Sun in 1 year. The Sun revolves around the galaxy in a galactic year, which is 250 million years.